My name is Christian, and today we'll be talking about automation of Citrix ADC using the NITRO API. We'll go over some of the use cases for automation and be demonstrating the process to complete the actions from searching the NITRO API documentation to testing in Postman to writing the script and verifying it, and finally integrating with other systems. So on our agenda today, we'll start off with the business case for automation. Why would we actually want to use automation? And we'll go into common tasks to target for automation, what makes it a good candidate for automation, and then a high-level discussion of what the NITRO API is, why do we want to use it, and then also how do we use it. We'll go into some introductory demonstration explanation. So we'll go through the documentation of the Citrix NITRO API, and then we'll get into some deep dive discussions and demos. The use cases we'll build out and then show how they're completed. All right, so let's kick this off with business cases for automation. Why do we want to actually use it? Great one is force multiplication. So at every company, there's a finite amount of people, and those people can only do a certain amount of things. So if we have scripts that can take some of the mundane or repeatable tasks off their plate so they can focus on the more important projects, that multiplies your force. We can reduce cost. After the script is developed, it doesn't cost anything to run it. You're not paying another person to do those mundane tasks. It reduces the time to deliver. So a network team with 4 people may have their plates full all the time. And when you submit a ticket to, say, create a load balancer, that ticket might not be the top of their priorities. So that ticket that takes a couple minutes to actually do is now over 2 days. So with a script, and automation, we can, as soon as you submit the ticket, create the load balancer for you. It's going to reduce errors. If you're like me, I have fat fingers. I type a lot of things wrong. So with that, accidentally typing something wrong could cause an outage in the environment or cause something to be misconfigured. With a automation, we do the process exactly the same every time, gets rid of errors. And then we can reduce audit and compliance reporting time. I don't know about you, but when I get a ticket that comes to me, I submit the change control in, I do the change, and then I don't always close it right after. With automation, we can tie that ticket creation and closing into our workflow, so it happens every time immediately. Along with reducing all of those, we can increase time to innovate. Taking those mundane tasks off your plate, we can do more important things like move the business forward. Increases efficiencies. 9 times out of 10, the script is going to do it faster than you can log into the NetScaler appliance. We can do consistency and standardization. If we just tell them, give me the name of your application, and we make it the exact naming convention in our script, we have consistency and standardization of the naming convention. And it's going to increase auditing and compliance visibility. Automation essentially reduces tribal knowledge in shadow IT, and combats skills and time shortages. Again, people, you only have a finite amount of people, they only have a certain amount of time, so doing scripts to do mundane tasks increases that time. And also on your network team, if you have 4 people, 2 of them are probably good with NetScalers, 2 of them might be good with firewalls. Those 2 that are good with firewalls can do the same tasks with automation. So what are some common tasks to target with automation? Creating new load balancers. The task is repeatable. So you have to create the load balancer, you have to create the service group, you have to create the backend server, and then you bind them all together. Same process happens every time. So this is easily automated. Enabling and disabling backend servers. Your application owners are constantly taking servers out of the service groups to do patching or upgrades, but it takes a while to take them out. So what we can do is just automate the enable or disable of the backend server and let the application owner do it. Creating certificates. Certificates expire all the time. The time to actually create it does take a while. So automating that will allow us to free up some time as well. And troubleshooting. If you have a complex configuration for, say, your website on a NetScaler, it sometimes takes hours to get through and find what the root cause is, where with the script, we can scan everything very quickly, generate a CSR, and we have all that information at the tips of our fingers within a few minutes instead of a few hours. And auditing and reporting. Common requirements for automation all should have change management. So you should create a change order. They should be tracked via tickets or requests, so change controls. They should all be documented very well. Who did it, what they did, and what time they did it. And they should all be logged for audit purposes. So next, let's jump into a high-level overview of what automation is and taking the DevOps approach. So what is the NITRO API? The NITRO API is Citrix version of a REST API. Essentially, a REST API allows us to get or put data from a system without the use of a web GUI or command line. The data is gathered by sending a request to one of the REST API's endpoints. So we can send a request, we can send a GET, which gets information that's already there and gives it to us. We can do a POST, which creates, say, a new load balancer with the specifications we tell it, or we can do something like delete. Once the NetScaler gets the information, it's going to process it and send us back a response in either JSON or XML. The good thing about JSON and XML are they are easily formatted, so you can read it. It's not just a huge blob that is a mountain to read through. So let's go ahead and compare what the manual approach is versus the automated approach. In the manual or traditional approach, a user has to log into either the GUI or the CLI. They have to know the format, the terminology, and the order of operations to create objects. So they have to have some sort of knowledge of the system to actually create a load balance V server. The automated approach is anybody can go in to, say, Jenkins, fill out the form with the web application name, the backend server name, and the backend server IP, click go, and it does it for you. So you can see that automation makes it simpler and makes it more available for more people to use. So then we'll talk about why do we want to use the NITRO API. It's designed for automation and DevOps. It's simplified input and output. Like I said, JSON and XML are very easy to read when formatted. It's well documented and supported. We'll go through some of the documentation of the NetScaler NITRO API here shortly. It's easy to test and implement. Within 20 minutes, you can probably go from the documentation to writing a Python script to verify what you're actually trying to do, whether that's get information or post information. They're extensible. If we need to build out additional functionality, you can build your own REST API with Flask or Django and get everything done without ever touching a CLI or a GUI. We can support multiple types of authentication, whether that's basic, certificate, whatever what have you. In this particular example we'll be using basic just because it's a lab. And it supports encryption. So we can have SSL encryption going to the REST API and coming back from it as well. Make sure all our data is protected. Now that we know why we should use it, let's go over how we should use it. And let's just use a story. I'm an application owner, and I want my application load balance configurations to be created without the networking team. So how would I go about doing that? We need to get an inventory of what we actually need to interface with. In this particular case, it's going to be the NetScaler. Then we need to get access. So we need to figure out what permissions we need on the NetScaler, whether it's NSRoot, super user, admin, read, write. Once we have all of the access we need to explore the API. So that's looking through the documentation, testing with Postman and curl, maybe a Python script, sending requests to the NITRO API. Once we have our testing done and we're comfortable with it, let's go ahead and go back to that documentation and see if the API matches the capabilities we need. In our particular case, we would need to create a load balancer, we need to create a service group, we need to create a backend server, and we need to bind all of them together. We're in luck because the NITRO API does accommodate all of those, so we get a check there. The next stop we're going to make is make the minimum viable product. This means we create the script and maybe it has hard-coded IP addresses or names for the backend servers, but we can show something that is an actively working prototype. We show that to the stakeholders and they give us feedback. They say, yes, we want to go forward with this, but we want you to integrate with X, Y, or Z. So from there, we update and revise the minimum viable product. All right, so next we'll go into some demos and exploration of the NITRO API, including the NITRO API client, the API documentation. We'll do a little bit of CLI, and we will do some testing during with Postman as well. After the high level, we'll go into some deep dive demos, enablement and automation of creating virtual IP addresses in Dev, enabling app owners to enable and disable their V servers, and then we'll do triggered automation as well, renewing a certificate and gathering root cause data for troubleshooting. Before we jump into the lab, I just want to review what we have in it. We have an Ubuntu server which hosts Docker. One of the Docker containers is Jenkins, so that's going to be kicking off all of our jobs for us. Jenkins will kick off Python scripts that are held in GitHub to send requests to the NITRO API. And then after the NITRO API is complete, it actually sends requests to Jira to create a ticket. Okay, so let's jump into the NITRO API. If you look over on my screen now, we have the documents for the NITRO API. You can see on the side here, there are a ton of different configuration items that we can actually complete. For our example of creating a load balancer though, we will need to go through and we would need to go to LB and LB server to figure out the capabilities. In the center of the screen right now, you can see there is a ton of different inputs we can give it to set specific settings on the NetScaler or the load balance V server. We're going to skip that for right now and just go to the operations so we can get a better idea of what this endpoint does. And we can add, we can delete, we can enable, we can get all of the load balancers or get a specific one. So it gives you a feel of what all we can do with this particular endpoint. Below that, we are going to get a description of what kind of authentication we actually need. In our use case in the demo, we are going to be using the xNitro Pass and user. So that's going to be our username and password for authentication. If you were going to build this out in a production environment, you could also use an authentication token instead of a username and password. Once we get through the authentication methods, we can go ahead and get into each one of the actions. So the first one is add. This would be the URL that we are going to send the request to. It is of method post, and it requires a couple headers. Their example is for the cookie for authentication, and then you also need a content type application JSON header as well. And then we craft our payload, LBV server, and you can see there are a ton of different options we can configure on it. We can send all of them with specific values to the NetScaler. In our particular case, we're going to focus on the name, the service type, the IP address, and the port. So we're going to keep it simple today. Scrolling down through here, we can see there are also all of the other ones and explanations on how to use each one of them. So delete is you give it a specific name of a NetScaler or LB bit, and it's of type delete, update, so on and so forth. So that is the NITRO documentation. Let's go ahead. We can log into our NetScaler here quickly. And let's take a look at the NITRO API client. Now that we've looked through the documentation itself, you might feel a little bit comfortable going in here and trying some things out. So if we go into configuration, it's the same exact setup as it was on the web page. So we'll go to LBV server and we can come up here and let's just do something simple. We'll do a get all. Click go. And we have an HTTP 200, meaning it was successful. So we sent the request successfully. And if we scroll down a little bit, you can see there's this huge blob here with all the information. It's a little tough to read it in this format, But if you would take this URL and just paste it in your web browser, we can see there is a much nicer format. This is JSON formatting. So we can see we get the name of each one of the load balancers, the IP address, the port, so on and so forth. So after exploring through here a little bit, you might get comfortable and start working on a different system, such as Postman. And right here, we have the same command. So we can send a request to this endpoint of type get, and we will get all of the same information. So we can see VSLB01 and the IP address, everything that is on there. We can do the same for a service group on a specific load balancer. So let's go ahead and send that. This is going to come back 200 OK, so successful. And we get the name of the load balancer and the name of the service group bound to it. Now, using get is cool. We can get information from it, but ultimately for our purposes, we need to create things. So let's go ahead and test some post request to the NITRO API. The first part in our use case was creating a load balance V server. So we would go to the LB V server endpoint with type post for an add, as the NITRO API documentation told us, and we had to send it a payload. So we have our LBV server, the name of it, the service type, and the IP address and port. So let's go ahead and click send on here. We can see we get a 201 created, but no body. That means it's successful. Coming back to our NetScaler, we can come over here and go to configuration, traffic management, load balancing, and virtual servers. We can see our VSLB test is now created without ever having to go into the GUI or CLI. We can do the same process with service groups. So you can see it's NITRO V1 configuration service group, and we need a smaller payload. It's just the service group name and the service group type. Let's go ahead and send that. We get another 201 created. Coming down to the service groups quick, we can see that's also created. Now the next step is actually binding them together. So you can see right now we don't have any service group bindings. Let's go back to our Postman, go ahead and bind. So this one is under the LBV server service group binding endpoint. And all you need to supply it with is the name of the V server and the name of the service group. Let's go ahead and click that. 201 created, meaning it's successful. And we'll go back and refresh this. So now we can see we have the load balance service binding. Similar to creating, we can also do deletions from the API. So we can delete that LBV server we just created. So VSLB test, go ahead and send that. We can see a 200 OK, meaning it's successful. And we can do the same with the service group. So let me go ahead and send that as well. So 200 successful. If I come back over here and refresh, they're gone. So that is testing from a high level, getting into the process of creating a script using Postman and NITRO API documentation. Let's go ahead and jump into the deep dives. So our first use case is going to be enabling developers to create VIPs in Dev. I don't know about you, but when I submit a ticket and I need a load balancer created, the network team might not have it at the top of their priority list. So it might take a couple days to get it done. Whereas with this, it may take 30 seconds at the most. As soon as you fill out the form, it's going to go ahead and do all of it for you. So the background on this is developers want to spin up swim lanes and application services all the time. They keep putting in requests. It's inundating the network transport team. This leaves an operations problem because load balancer configurations aren't at the top of the team's list. Like I said, might take weeks. It's also another operations problem because there's a lot of tickets. You have to create a ticket for every one of your requests. Then the network admin has to create a change control for that, do the work, close it out, and then add the change control to the ticket, close the ticket out. So that's a lot of extra work to do a simple task. So the solution to this would be to use DevOps tools and NITRO API to allow an integrated and automated configuration without direct access to the ADC. So we're not giving the developers access to the NetScaler where they may, mess something up with 1,000 different V servers on there. It is easy to accidentally misclick the wrong one and delete it or disable it, causing an outage somewhere. So we do all the work for them. They just tell us what they need done. And we'll achieve this using Jenkins, Python, the NITRO API, and Jira Service Management. The workflow is relatively simple. We have the server. We have the server, which is Jenkins, that is going to connect to the NITRO API, authenticate, and then it's going to do a post request to create the load balancer, create the service group, create the backend servers, and then bind everything together. Once that's complete, we're going to generate a Jira ticket via its REST API, implementing or showing what was all done. So let's go ahead and jump into this. First, I'll show you the manual approach to it, and then we'll jump into the automated approach. So this process isn't super time consuming, but it is very repetitive. So we could go into here, we can call this just test, and we'll give it an IP address. And click OK on here. Next from there, and the workflow, we need to create the service group. So let's create the service group, call that one test as well. And then finally, we need to create our backend server. So I'll do server-based. We need to give it a port. So port 80. Okay, and then bind everything together. Okay, so the process is done, but it did take a little bit, and that may not be on the top of the priorities list. So from moving from the network team to the developers, we can go ahead and do something like this Jenkins job here to create a new load balance V server. What we can do is build it. We have our IP address of the NetScaler, the name of our application. I want this application port to be 443 and of type SSL. And we give our backend server and our IP address. So let me go ahead and click build on there. Let's take a look at our output. And we can see here, these are the IP addresses that were used. This is the IP addresses that are in our range. This is the first available one. This is the name of the virtual server and the service group. We completed all of our builds and binds, and we created a ticket in Jenkins.
Christian, this is Anthony. You may want to slow down just a little bit because I'm seeing a delay between what you're showing and what you're saying.
Sure. Okay. So this is the output. This is all the IP addresses that we are saying are allowed to be created. This is the first IP address, and this is the name of the virtual server and service group. Now, we did the automation of the first IP address and the service group name because developers might not know how a NetScaler works completely. So they might just pick an IP address that's already in use. That may cause an outage somewhere else. And if you are creating multiple load balancers for the same application, that application field just says, what's its name? Well, it's always web app. So you can't create multiple load balancers with the same name. So we use a function to create a random number. If we take a second to just look here, how we did the picking IP addresses is we used a Lambda function. And in our Lambda function, essentially, we have two different inputs. We have an input that is from the REST API. Essentially, we send a request that says, give me all of your IP addresses on the NetScaler. Okay, we have that. We create that into an array. Next, we create our array for our range. So in our case, we say any IP address between 30 and 254 that isn't in use is a potential candidate for a new IP address for a load balancer. Then we go through our Lambda function. We subtract the first set from the second, and then the second set from the first to make sure that we have the lowest possible IP address assigned to it. So if I created a new load balancer, we would have 31, 32, 33, so on and so forth, and it'll fill it up from the lowest number to the highest number. Okay. If you guys have any questions, feel free to put them in the in the chat. We will be picking them up at the end. All right. So our next use case is going to be enabling developers and application owners to enable or disable servers in their load balancing or content switching configurations. Background on this: application owners are constantly requesting backend servers to be removed and re-added from service groups for patching and upgrades. Once a week, twice a week, they're probably requesting to get it done. And the task is tedious and repetitive and requires a change control. So the task itself maybe takes 2 seconds, but the change control to actually create it or do the task takes a couple minutes, and then you do the task, and then you got to close it out, put it on the ticket, close out the ticket. So that entire process takes 10 minutes or so from the time that you get it to the time that you can close it potentially. Now that also leads to that network person may not see it right away or may not have the time to do it right away. So that takes a little bit longer. So how can we make this faster? We can enable application owners to disable and enable their backend servers, and then automatically submit that ticket or that change control to notify of what changes are made with Jira. The workflow is relatively simple. So we'll have our Jenkins server connect to the NITRO API and then authenticate. We will get a list of the backend servers. We need to get all the IP addresses. We'll compare the IP addresses to the one we submitted, and then we will post either disable or enable the server. Once that's complete, we'll create our Jira ticket saying, hey, this is what changed. So let's go ahead and go into this use case. Back on our NetScaler over here, if we want to take a look at the manual process, we would go to servers over here, and we could select one of these servers. Use the dropdown and disable it. So like I said, this process isn't very long. It's the tickets and the paperwork that comes around this. Enabling this again, a couple clicks, and we're already back up. That takes time away from the network team to innovate or work on their bigger projects. If we have a simple workflow, such as this one right here, we can give this to the developer, and in the ticket, it's going to have the NetScaler, all of the IP addresses they own for their backend servers. So if I wanted to disable 42, for example, and we give them the option to either disable or enable it. So if I want to disable this 42 because I'm doing patching, for example, let's go ahead and send this ticket, and let's take a look at the output. So we can see we got a 200 response. That means the server was actually disabled. And we have a ticket submitted for us already saying, hey, this change was done. So we have our ticket right here. On the NetScaler, just to verify, if we refresh over here, we can see that Web02 is disabled actually. Okay, so now I finished my patching and I want to put it back in the service group. So all they have to do is come in here, select 42 and select enable. Whenever they click build on here, we can go take a look at the output, see a 201, it completed successfully. So the process for them becomes a lot easier. There's less paperwork in it. The automation does all of that for them. So let's move on to the next use case, which would be renewing expired certificates. A report is generated weekly or daily to say these certificates are going to expire today. The network team has their hands full every day, putting out fires, all their different projects, and sometimes they don't get to the updates. This causes a security problem because expired certificates can break applications and they create security issues. This also causes operation problems because, if many of you know, the process of generating a certificate is actually kind of a long one. If you're using, OpenSSL, you can create an X509 request or CSR. You have to submit that request to the certificate authority. You have to get it approved probably by somebody. Once that certificate's completed, you have to upload it to the NetScaler and then bind it on the NetScaler finally too. So that process takes a long time. and it takes you away from your tasks. So the solution for this would be to automate renewing the certificates. I want to mention that the process we're going to go through in this lab is going to be the building blocks for automation. Right now, we do most of the process forward, but we have to actually kick it off. We could integrate this with something like a SCOM alert saying, hey, your certificate's expiring today, and it automatically kick off the process to renew it. So in our lab, we have our Jenkins server that is going to generate the CSR and key, and then it's going to copy it to the certificate authority, generate the certificate, copy the certificate back, and then we move the certificate and key to the NetScaler, create the pair, and then bind it to the LBB server. Once our process is complete, we're going to create a ticket in Jira saying this was, updated. So let's go ahead in here. A quick look at the code. We have a couple functions. So we generate our CSR automatically here. And then we go ahead and we SCP over the certificate to our certificate authority. And then we run this PowerShell script here that chooses the template, so a web server template, and it chooses the certificate authority we actually want to execute, and it actually generates our certificate for us. Once the certificate is complete, we copy it back and we close the SSH connection. And then finally, we have to copy it up to the NetScaler. So we SSH in, copy it up to the NetScaler, and then we use our NITRO API to create the certificate key pair and then bind it to the LBB server. So let's come over here to our Nitro demos and change certificate just to make sure we're here. Let's go ahead and build with parameters. Our host name, we can change it to whatever we need. In this particular case, we'll call it web app. We can change, maybe I'm in Texas today, so I'm in Austin, Texas. We can change our OU to webinar. And then do we want to bind it to a VIP? Yes, we do. Which NetScaler do we want? And then the IP address of the actual VIP. Let's click go on here. And after a few seconds, it's automatically going to be done for us. So we can see here, we can find out where the web key and CSR are. We can see that the certificate was successfully retrieved from the certificate authority, what ticket number it was. We can see a successful bind to the NetScaler. And then finally, we have our ticket. So if I click on this ticket here, we can see web app certificate was updated, and we can add more fields, more information. For the purposes of this demo, we just kept it simple for the tickets. So a process that used to take, maybe an hour, depending on how long it took to approve the certificate at the certificate authority, now is done in seconds. All right. Let's get on to our final use case, gathering root cause data for troubleshooting during outages. So the background on this, like I said earlier, most of you probably have complex configuration of load balancing somewhere in your environment. Websites, with hundreds of redirections, you have to have a complex configuration for it. And the problem with that is when you have hundreds of load balancers that are for the same application, you probably don't have the strongest naming convention. It's probably web app 01, web app 02, or web app -1, web app -2, web app -3, so on and so forth. So that makes it tough to just jump in there if you're not completely comfortable or with it and find out where the root cause is quickly. Having to troubleshoot complex configurations cost money and interrupts other scheduled work. And the solution to it is automate the task of the recon, so getting all of the information, the service group states, the backend server states, the LBB server states, automate the collection of that, create a report, and then send it out to everybody. So again, with this demonstration, this is building blocks to automation. We will be kicking off the process manually, but with a SCOM alert, for example, the alert could come in, say the service is down. Jenkins can automatically run this job, give you the report, send you an email. So within minutes, you can have a report of what's going on in the NetScaler environment and start troubleshooting the exact root cause. The script itself is going to kick off. It's going to connect and authenticate. It's going to get the load balancer state, the service group state, the service group member state, and then any custom monitors that are going to be on there, any custom URLs. And then once all of that is complete, we are going to curl to the backend server with the monitor string, if there's a custom one, and make sure that that server is the same state as what it says on the load balancer. So if it's up in the back end, but down on the NetScaler, we can say it's probably a network issue. We can start troubleshooting there. If we can confirm that, you know, the NetScaler says it's down and it's actually down, we can correlate that to the backend server having an issue, notify the app owner, they can start working on it. Once all of that is complete, we generate a CSV and we send a ticket to Jira. As I said before, we could also send emails to the line of business, security owner, whoever needs them. So let's go ahead and jump into this configuration. Going back to Nitro demos, we'll do NetScaler checks this time. And like I said, this can be kicked off automatically, but in our case, we're doing it manually. So all I have to do is click build. And let's check the status on this. While this is running, think about how long it would take to look through thousands of vServers. With this, as you can see, we only have 12 vServers right now, but the process was 10 seconds and we have all the information we need. We can see up here, we have a nice table. It had to be broken onto 2 lines, unfortunately, but it gives us all the information that we're looking for. We have the vServer name, the service group name, this backend server name, what port it is, the name of the monitor, what the monitor actually is requesting, the LB vServer state, service backend server state, and then what it actually is when we do a curl. We can quickly identify that if we were troubleshooting this configuration, this IP right here is probably the culprit. Scrolling down, we have it in a slightly different configuration here, just so it's a little bit easier to read. And we could go ahead and say, okay, Web04 is having an issue with this particular monitor. Let's go ahead and troubleshoot it down there. We roll out the network. Along with that, we also created a ticket in Jira. So going in here, we troubleshooting gathered this data. And we have an attachment right here. And that attachment is actually the CSV file we generated. So let's go ahead and take a look at this. Can't scroll up, but it's going to be similar to the tables that we displayed on our Jira page, or our Jenkins page. So we can see all of the states, everything like that. This is something that we can send out to whoever needs it. Okay. So in summary, we want to automate repetitive tasks. So creating load balance vServers, disabling and enabling servers, renewing certificates, and troubleshooting are all repetitive tasks that use the same steps. We want to go ahead and automate those to alleviate them from our lives. And automating repetitive tasks saves time and money. If I don't have to disable a server every 10 minutes or every hour, that allows me to focus on my actual tasks and be more productive. We also reduce risks and errors. In our first script, creating a load balancer, we removed all chances of having errors in it by generating their IP address and generating essentially a random name for their load balancer. This allows for us to reduce the risk, no fat fingering, and it reduces outages. And then we designed this around a framework to support artifacts. We generated a ticket after every one of our changes, and we have an exact log in Jenkins of exactly what happened. So that allows us to keep up with security and audit Every time you make a change, know that you already had a ticket submitted, you're good. And along with that, we're allowed to innovate more. With more time, we can do things to further the business.